Welcome to Module 9 of the Works Clearinghouse WWC Group Design Standards Training. You can access all the resources mentioned in this module through the WWC's website, whatworks.ed.gov. This module focuses on the WWC's procedures and standards for reviewing group design studies, where researchers used imputations to handle missing baseline data, missing outcome data, or both. We will describe the approaches for handling missing data that the WWC considers acceptable, and we will discuss how the WWC's study review process will vary depending on the type of missing data that study authors imputed. Despite their best efforts, sometimes researchers are unable to collect data for all participants in a study sample. Research studies may have missing outcome data, missing baseline data, or both. For instance, research studies might have collected complete baseline data from all participants in the sample, but are missing outcome data from some participants due to sample attrition. Also, it is possible for research studies to have collected complete outcome data from all participants, but still have some missing baseline data. For example, some participants in the sample may have been absent from school on the day of the baseline data collection. And finally, it is possible for studies to have both missing outcome and baseline data. So why does the WWC care about missing data, and how researchers handle it in group design studies? Missing data can introduce bias and other analytic issues if participants with missing data systematically differ from those with observed data. For example, consider research studies examining the effectiveness of high school dropout prevention programs. In these types of studies, students who drop out of high school may be more likely to have missing outcome data, but these same students are also more likely to be lower performing than those students who do have observed outcome data. To address missing data, study authors can use a variety of analytic approaches. For instance, they might focus on the analytic sample of participants for which all data were collected, or they may even impute values for the missing data so that more participants can be included in the analysis. The WWC's review process for group design studies with missing data will depend on the study's research design, the method the study authors use to address the missing data, and whether the study has missing baseline data, missing outcome data, or both. The first step in the review process for studies with missing data is to determine whether the study authors used an acceptable approach to address the missing data. The study authors must use an acceptable approach to address missing data to be eligible for the research ratings of meets WWC standards without reservations or meets WWC standards with reservations. This requirement applies to all data used in the analysis, whether for an outcome measure or a baseline measure, including any baseline measures required for assessing baseline equivalence. This table shows the acceptable research designs, the different types of data that can be imputed, and any additional requirements that the WWC has for a missing data approach to meet the WWC's standards. For example, complete case analysis is an acceptable approach for handling missing data in any type of group design study and is acceptable for handling both missing baseline data and missing outcome data. In fact, although complete case analysis is a part of the WWC standards for missing data for the sake of completeness, studies that use complete case analysis are handled by the WWC standards for attrition and baseline equivalence. Any group design study using complete case analysis will be assessed only under the compositional change and baseline equivalence standards, and will never need to meet any of the additional requirements for studies with imputed data. Regression imputation methods are also acceptable for any type of group design and for handling either type of missing data. But the WWC has additional requirements in order for this type of approach to meet standards. Namely, the regression imputation model must be conducted separately by condition or include an indicator variable for condition. It must include all covariates used for adjustment in the impact model, and it must include the outcome when imputing missing baseline data. Dummy imputation methods only are considered an acceptable approach for handling missing baseline data in uncompromised randomized controlled trials or RCTs. Maximum likelihood is acceptable for any type of design and for handling either type of missing data. But the WWC requires the study authors to report using a standard statistical package to implement the method, or they must include relevant citations to methodological support for the method used. And finally, non-response weights are acceptable for handling missing outcome data in any type of design. But the model used to predict missingness must estimate probabilities of missingness separately by condition or must include an indicator variable for condition, and it must include all baseline measures required for baseline equivalence. So, at this first step in the review process, reviewers will assess whether the study authors used an acceptable approach to handle their missing data. At this step, there are additional considerations required for cluster-level assignment studies that analyze individual-level data. In these scenarios, the approaches that the authors use to address missing outcome data must account for the non-independence of individual observations within clusters. This is often done using techniques like multi-level modeling or robust standard errors to account for the dependence of observations within clusters. So, in these scenarios, in order for the WWC to confirm statistical significance of findings in a study that uses regression imputation, maximum likelihood, or non-response weights to address missing outcome data, the study must provide evidence that the approach appropriately adjusts the standard errors for clustering by citing a peer-reviewed journal article or textbook that describes the procedure and demonstrates its effectiveness. If authors do not include an acceptable adjustment for clustering, the WWC will not apply its own adjustment for clustering, because it may not be accurate for analyses using imputation methods. The WWC currently does not have a recommended method of calculating standard errors when using imputation methods in cluster-level assignment studies. So, the burden for demonstrating that the approach is appropriate rests with the authors. So what if a study uses an approach to handle missing data that is not listed in the table on the previous slide? If study authors use a different approach that is supported by a citation of a peer-reviewed journal article or textbook that describes the procedures and demonstrates it can produce unbiased estimates, the WWC may consider it an acceptable approach after review by experts. If so, the WWC will release guidance that updates the list of acceptable approaches. Study findings that fail Step 1 in this process are not eligible to meet standards, so the missing data review process will stop. But for studies that do pass Step 1, reviewers will proceed to the second step in the process. At this second step, reviewers will assess whether the study is an RCT with with a low risk of bias due to compositional change. Individual-level RCTs satisfy this requirement by demonstrating low attrition. Cluster-level RCTs satisfy this requirement by demonstrating low cluster-level attrition, low individual-level attrition, and excluding any high-risk joiners from the analytic sample. When calculating overall and differential attrition rates, reviewers should remember that units with imputed or missing outcome data are counted as attrition. Some techniques for handling missing data, like maximum likelihood methods, can include units with missing data in the outcome analysis without imputation, but these sample members would also be counted as attrition. Again, the WWC counts sample members with imputed or missing outcome data as attrition, since they can introduce bias if the patterns of missingness depend on unmeasured factors. At this step, if the study is an RCT with a low risk of bias due to compositional change, it is eligible to be rated meets WWC standards without reservations. This is because the amount of missing or imputed data in these types of studies is unlikely to lead to bias that exceeds the WWC's tolerable level of potential bias. However, if a study fails this step, the review will proceed to step 3. So, this means that all individual-level QEDs, compromised RCTs, and RCTs with high risk of bias due to compositional change will proceed to the next step. Before we move on to the next step, let's discuss an example of how to assess attrition in studies with imputed outcome data. Imagine a study where researchers assigned 50 students to an intervention group and 50 students to a comparison group. By visiting schools one day before and one day after the intervention, researchers obtained data for students in various combinations, with their sample sizes reported in the table on the right. Using a regression imputation model meeting WWC standards, the analytic sample included students who had pre-test and/or post-test data. How do we calculate attrition for this example? Well, recall that we calculate attrition based on the number of participants with missing or imputed outcome data. Information about the number of participants with missing or imputed baseline data can be useful in steps 3 and 5. However, for calculating attrition, we only are interested in the outcome data. In this case, 5 intervention and 10 comparison group students have missing outcome data. So, there are 15 students overall with missing outcome data. This corresponds to 15% overall attrition and differential attrition of 10 percentage points. What happens to cluster-level assignment studies after step 2? Importantly, the remaining steps in the missing data study review process only apply to individual-level assignment studies. If reviewers are reviewing cluster-level assignment studies, reviewers will assess step 1 and 2 in this process. Reviewers should use the standards for assessing cluster-level baseline equivalence to attempt to complete the review. If the sample of individuals used to assess baseline equivalence differs from the sample in the analysis of outcomes. The third step in the missing data study review process involves assessing whether the study authors limited potential bias from missing and imputed outcome data, if any such data were missing or imputed. These designs are eligible for the research rating of meets WWC standards with reservations if they limit the potential bias from using imputed outcome data instead of actual outcome data. This requirement does not apply if the study imputed only baseline data but did not impute any outcome data. The imputation methods that the WWC considers acceptable are all based on an assumption that the missing data depend on measured factors but not unmeasured factors. If this assumption does not hold, then the impact estimates from the study may be biased. This is why the WWC requires these types of group design studies to use approaches that demonstrate that they limit the potential bias from imputation methods to less than 0.05 standard deviations. An analysis of a sample with imputed outcome data can produce biased estimates of the intervention effect if the participants with observed data differ from those with missing data, and some of the differences are unmeasured. In these hypothetical examples, if outcomes could be obtained for all sample members, then the average for participants with observed outcome data would differ from the average for those with missing outcome data. Comparing the differences in these means for the intervention and comparison groups, if known, would indicate the magnitude of possible bias. However, because the missing outcomes are not observed, the WWC instead assesses the degree of bias using baseline data. The WWC estimates the potential bias from missing outcome data due to unmeasured factors by comparing the means of the baseline measure specified in the WWC Procedures and Standards Handbook, or the Handbook, as required for assessing baseline equivalence, separately for the intervention and comparison groups, and for two samples. The first sample is the complete analytic sample. The second sample is the analytic sample restricted to cases with observed outcome data. A smaller difference in these two means within one or both conditions lowers the likelihood that the missing data are related to factors that lead to bias in the impact estimate. Appendix H in the handbook provides additional technical detail for those who are interested. In order to translate the group differences in baseline means into an estimate of bias in the outcome effect size, the WWC uses the pooled standard deviation of the baseline measure and the correlation between the baseline and outcome measure. Again, Appendix H in the handbook provides the technical formulas that the WWC uses to estimate potential bias. The formulas used to assess this bias also differ if the baseline measure is not observed for all participants in the analytic sample, or if the analyses use non-response weights. If these data are not reported in the study, then the WWC will request this information from the study authors. Studies that use complete case analysis do not need to complete the bounding exercise, as they do not have any imputed data. Before we move on to talking about the next steps in the review process, let's discuss the type of information reviewers will need to gather from studies that impute missing data. As we noted before, the information reviewers need to gather depends on factors, like the type of imputation method and whether data were missing in the outcome measure, the baseline measure, or both. One of the common and simplest examples are studies where there are complete baseline data, but outcome data are missing for some individuals. No matter what kind of bounding exercise you are doing, you always will need the correlation between the baseline and outcome measures. The correlation is key because the baseline measure will serve as an important predictor of the imputed value of the outcome for any individuals with missing outcome data. The stronger the correlation, the better the imputation will be. In this example, the group on the left is the full sample. From them, we will need the means and standard deviations of the baseline measure separately by intervention and comparison groups, as well as the sample size for each group. On the right is the subset of individuals who have complete outcome data. From them, we will simply need the means of the baseline measure. With this information, the online study review guide will provide estimates for the bounding exercise and determine if a study limits bias from imputed data. But how does it use that information? Well, as we have already discussed, the WWC uses information about the baseline covariate to bound the possible bias due to imputed outcome data. The WWC actually estimates 3 different bounds. The first bound is an estimate of the possible bias in the comparison group, outcome mean. In this formula, and all the rest on this slide, the term that looks like a P is rho and represents the baseline outcome correlation. The second bound is an estimate of the possible bias in the intervention group outcome mean. And the third bound is an estimate of the possible bias in the impact estimate, or the difference between the intervention group outcome mean and the comparison group outcome mean. And as we have discussed elsewhere, omega is a bias correction term for small sample sizes. Note that these formulas may look slightly different than what you see in Appendix E, just rearranged and condensed for space. The standard deviations and sample sizes of the full sample are used to calculate the pooled standard deviation of the baseline covariate, called SDX. Then the WWC calculates a difference in means using the full sample comparison group means and the comparison group mean for just the individuals with complete outcome data. Then, difference in means is scaled using the correlation between the baseline and the outcome measures. The larger the correlation is, the smaller the scaling factor is, and the smaller the final difference in means will be. The other 2 bounds are calculated in a similar manner, and if all 3 bounds are less than 0.05, then the WWC considers the risk of bias due to imputed data to be small. If any of the 3 bounds are larger than 0.05, then the finding receives a research rating of does not meet WWC standards. The bounds calculated under the more complicated scenarios, such as when participants have missing data for both the baseline and the intervention, will require additional values. However, these values will be similar information regarding sample means, standard deviations, and sample sizes of different groups with missing or complete data. Findings that are judged not to limit bias due to imputed data fail the 3rd step in the missing data review process are not eligible to meet WWC standards. For high attrition, RCTs assessed under the optimistic boundary for attrition if study authors impute outcome data for the full sample that was randomized to conditions and analyze those data. The study need not satisfy the baseline equivalence standard at Step 5 to be eligible to receive the research rating meets WWC standards without reservations. Imputing missing outcome data and analyzing the full randomized sample preserves the integrity of the original randomized groups. However, high attrition RCTs assessed under the cautious boundary with imputed data still need to include an appropriate adjustment for baseline covariates specified in the handbook, typically a pretest in the same domain. This parallels the requirement for high attrition RCTs without imputation for missing data. So, if a study passes Step 4, it is eligible to receive the research rating of meets WWC standards with reservations, and the missing data review stops at this stage. Otherwise, if a study fails Step 4, it will progress to the fifth step in the missing data review process. This means that all individual level QEDs, compromised RCTs, high attrition RCTs that do not analyze the original randomized sample, and high attrition RCTs assessed using the cautious attrition boundary must proceed to the next step. Studies that use complete case analysis also proceed to the next step because they do not have imputed data. The fifth step in the missing data study review process is to assess whether data in the analytic sample have been imputed for any baseline measure specified in the handbook. QEDs, compromised RCTs, and high attrition RCTs that do not impute data to analyze the full randomized sample, or high attrition RCTs assessed using the cautious boundary, must satisfy the baseline equivalence standard to be eligible to be rated meets WWC standards with reservations. Reviewers should proceed to Step 5A if the study has no missing or imputed baseline data for all measures specified in the handbook as required for assessing baseline equivalence, including studies using complete case analysis. Otherwise, reviewers should proceed to Step 5B if the study had some missing or imputed baseline data for any measure specified in the handbook as required for assessing baseline equivalence. Again, Step 5A is applied if the study has no missing or imputed baseline data on those key measures that are required for satisfying baseline equivalence. In this scenario, baseline equivalence is assessed using the usual approach that was described in the baseline equivalence module in this training series. In contrast, Step 5B will be used if the study did have missing or imputed baseline data on any of the key measures that are required for satisfying baseline equivalence. In this scenario, the WWC uses a slightly different process to assess baseline equivalence. The WWC will estimate how large the baseline difference might be under different assumptions about how the missing data are related to measured or unmeasured factors. The largest of these estimates in absolute value is used as the baseline difference for the study. Just as in studies with complete baseline data, a study with missing or imputed data for a required baseline measure is eligible to be rated meets WWC standards with reservations if the largest estimated baseline difference does not exceed 0.25 standard deviations when the analysis includes an acceptable adjustment for the baseline measure or 0.05 standard deviations otherwise. The WWC's approach used for estimating this potential bias is similar to the approach used in Step 3 described earlier. But instead of comparing means of the baseline measure, the WWC compares means of the outcome measure separately for the intervention and comparison groups and for samples. First, the entire analytic sample, and second, the analytic sample restricted to cases with observed baseline data. Again, a larger absolute difference in these means within a group indicates that the data may be missing in a way that is related to unmeasured sample characteristics, and the measured impact of the intervention may be biased. To translate the group differences in outcome means into an estimate of a baseline effect size, the WWC uses the pooled standard deviation of the baseline measure and the correlation between the baseline and outcome measure. Again, Appendix H in the handbook provides the technical formulas that the WWC uses to estimate the potential bias. The formulas used to assess this bias also differ if the outcome measure is not observed for all participants in the analytic sample, or if the analyses use non-response weights or complete case analysis. If these data are not reported in the study, then the WWC will request this information from the study authors. Time for your first knowledge check in this module. researchers randomly assigned 10 classes to use a history game intervention and 10 classes to serve as a business-as-usual comparison group. A standardized social studies achievement test was used as the outcome measure. Pre-test and post-test data were collected from undergraduate students in all 10 comparison group classes and 9 intervention group classes. Outcome data were not collected for one of the intervention group classes because the professor canceled class that day for inclement weather. The analysis excluded any joiners. Counting the missing outcome data as attrition, the study has low individual level attrition, low cluster level attrition, and high risk of bias due to joiners. Which of the following is true? A. Dummy imputation is an acceptable method for handling the missing data in this study. B. Maximum likelihood is an acceptable method for handling the missing data in this study. Statistical significance will be reported, provided the study gives evidence that the method they used appropriately adjusts the standard errors for clustering, and the authors used a standard statistical package or included relevant citations to the maximum likelihood method used. Or C, complete case analysis is the only acceptable method for handling the missing data due to the non-independence of the observations within the clusters. You may want to pause the video while you think about your answer. The correct answer is B. Maximum likelihood is an acceptable method for handling missing data in cluster-level RCTs. The WWC only will report on statistical significance if the study authors provide evidence that the approach appropriately adjusts the standard errors for clustering by citing a peer-reviewed journal article or textbook that describes the procedure and demonstrates its effectiveness. Knowledge check 2. High school students participated in an RCT evaluating a tutoring intervention implemented after regular school hours. The participating students were randomly assigned to an intervention group or a comparison group. The comprehensive test of basic skills, 4th edition, a standardized test, was administered to students at pre-test and post-test. Baseline data were collected from all participants, but because of student absences on the days post-test data were collected, post-test data were missing for some students. Average pre-test scores differed between groups by 0.24 standard deviations. The researchers handled missing outcome data by using regression imputation to analyze the full randomized sample for the impact analysis. Their regression imputation model included an indicator for condition and included all the same covariates that were included in the impact model. When analyzing the effects of the tutoring intervention, researchers used an ordinary least squares regression model, which adjusted for pre-test scores. The study is reviewed using the cautious boundary for attrition. Reviewers calculated that the maximum possible bias due to imputed missing data was less than 0.05 standard deviations. Before moving on to the response options, consider whether the missing data method used is appropriate according to the WWC's missing data standards, as well as the highest possible research rating this study's findings would be eligible to receive. You may want to pause the video now to think about your answer. Based on the scenario shown on the previous slide, which of the following is true? A. Findings from the study would be rated does not meet WWC standards because it is a high attrition RCT reviewed under the cautious attrition boundary that cannot satisfy the baseline equivalence requirement. B. Findings from the study would be rated does not meet WWC standards because regression imputation is not an acceptable method for handling missing outcome data. C. Findings from this study are eligible to receive a rating of meets WWC standards with reservations because the researchers imputed all missing outcome data to analyze the original randomized sample and used an acceptable adjustment strategy for baseline differences when analyzing the intervention outcomes. Or D, findings from this study are eligible to receive a rating of meets WWC standards with reservations because the researchers used an acceptable adjustment strategy for baseline differences when analyzing the intervention outcomes. You may want to pause the video while you think about your answer. C is the correct answer. High attrition RCTs that impute all missing outcome data and analyze the original randomized sample that use an acceptable adjustment strategy for baseline differences are eligible to receive a research rating of meets WWC standards with reservations. This is because imputing missing outcome data and analyzing the full randomized sample preserves the integrity of the originally randomized groups. This concludes the 9th module in the WWC Group Design Standards training. Let's review what we discussed in this module. We described the WWC's procedures and standards for reviewing group design studies, where researchers used imputations to handle missing baseline data, missing outcome data, or both. We discussed the approaches for handling missing data that the WWC considers acceptable. And we discussed how the WWC's study review process proceeds depending on how the study authors handled missing data for a given type of group design. Remember that you can access all of the resources mentioned in this module on the WWC website, whatworks.ed.gov.